Today we prove the Pythagorean theorem in one of the most visual ways possible, Euclid's area proof. The statement is a squared plus b squared equals c squared, but Euclid treats it as one square on the hypotenuse being filled by two imported areas. Start by looking at the three squares, one on CA, one on BC, and one on AB. So the theorem becomes a geometric puzzle. Can the two smaller square areas be found again inside the square on the hypotenuse? Euclid's key move is one auxiliary line through point C, parallel to a side of the c squared square. That line is perpendicular to AB, and it cuts the large square into a left rectangle and a right rectangle. Now look at the left small triangle. Triangle APC is similar to triangle ACB. That is the real engine of the proof, because similarity converts shape into a usable strip width inside the square on C. From that similarity, we get AP over AC equals AC over AB. So AP equals B squared divided by C. In other words, the width of the left strip is exactly the B squared area compressed by the side length C. Now multiply that width by the full height AB of the big square. The left rectangle has area AB times AP, and that becomes exactly B squared. So the left side square has been transferred into the left strip. Now repeat the same idea on the right. Triangle PBC is similar to triangle CBA. The proof has a beautiful symmetry here. The other side is not new mathematics. It is the same move mirrored. Similarity gives PB over BC equals BC over AB. So PB equals A squared divided by C. Now the width of the right strip is exactly the A squared area compressed by C. Multiply by AB one more time, and the right rectangle has area AB times PB, which is exactly A squared. So the other leg square becomes the right strip. Now step back and look at the large square on C. The two colored rectangles tile it completely. There is no gap and no overlap. So the two transferred areas together equal the whole square on the hypotenuse. That gives the final identity immediately. A squared plus b squared equals c squared. Not because we expanded anything algebraically, but because we watched two exact area transfers fill one exact square. And here is the whole proof in one clean list. A right angle, three squares, one auxiliary cut, angle-angle similarity, and rectangle area. Those five facts turn the two leg squares into two strips that fill the square on C. If you like this kind of geometric proof, subscribe to the channel.